Hello students, today we will continue with the formation of hydronium and hydroxyl ion. The formation of hydronium ion we did yesterday. See, a proton, if it is written a proton, it means they are talking about H plus ion. This we discussed yesterday. This H plus ion, it is released from acids. It adds onto the lone pair of electron. It adds onto the lone pair of electron of the oxygen atom here, this one, of the water molecule. And children, please put this arrow here. This should not be a simple single bond. I've seen your notebooks and you people have made a single bond here, like this you have done, like O, H, H and H you have written. This is the coordinate covalent bond, which is here both the electrons they are donated by oxygen atom, because H plus is here, which is totally electron deficient. So this coordinate covalent bond, it should be represented like this, and here a positive charge, it is necessary. Please make sure that you people have done this in your notebooks. Okay. Now H plus ion, they accepts the lone pair of electron, forming coordinate covalent bond. This arrow, coordinate covalent bond. Coordinate covalent bond, they are the bonds, or it is the bond which is formed between atom of a polar covalent molecule. Atom of a polar covalent molecule. In water it is oxygen. With a lone pair of electron, it should have a lone pair of electron and an ion which accepts the lone pair of electron. It should have a lone pair of electron and there should be an ion here, H plus ion, which should accept that lone pair of electron, and the bond which is formed is coordinate covalent bond, which is represented by an arrow. Now hydroxyl ion, formation from alkalis in aqueous solution, that is ammonia in aqueous solution. We know that ammonia, it is a basic gas, and when this ammonia it is dissolved in water, we'll get ammonium ion and hydroxide ion. Okay, ammonium ion and hydroxide ion, which is also called hydroxyl ion, and they together form ammonium hydroxide. Okay, so ammonia is a basic gas. When it is dissolved in water, we have H plus C. Here if you will see, this nitrogen being more electronegative, it is more electronegative, and that's why these hydrogen, they will become electropositive. Okay, partial positive charge will appear on these because of the electronegativity of this nitrogen atom. Here if we see, then oxygen is more electronegative as compared to hydrogen atoms. So here see, this hydrogen atom will combine with this nitrogen. This is partially negative and this is partially positive. When it will combine with this nitrogen atom, it will form a coordinate covalent bond here. Okay, it will form a coordinate covalent bond, which is represented here. It is represented like this because the bond is just formed here, having a positive sign in the whole entity, or it can be represented like this. Here the three bonds, these three bonds were existing here earlier in the ammonia molecule, and this is the newly formed coordinate covalent bond, and this hydrogen is from this water molecule, and it will acquire a positive charge. See, now OH is left with a negative charge on it, OH minus, hydroxyl ion. So here we get ammonium ion and hydroxyl ion. A proton, that is H plus ion, it is released from water. This H plus ion, it is released from water. It adds on to the lone pair of electron. This H plus, it adds on to the lone pair of electron. This nitrogen atom having a lone pair. Lone pair means the pair of electron which do not participate in bonding. Nitrogen atom of the ammonia molecule. Nitrogen atom in ammonia has a slight negative charge. It is slightly electronegative. That's why it will acquire a slight negative charge, and the three hydrogen atom, they will acquire slight positive charge. The H plus ion accepts the lone pair of electron. This H plus ion, it will accept this lone pair of electron. Accept means it will be shared between nitrogen and H plus, forming a coordinate covalent bond like this coordinate covalent bond with an arrow here. Ammonia is a polar covalent compound with a large difference in electronegativity between nitrogen atom and hydrogen atoms in the ammonia molecule. They have the electronegativity difference and it is a polar covalent molecule. Thank you class, and tomorrow we will start with the preparation of acids and bases. Thank you.